Well guys, we're back on the RCA. It's probably going to be kind of a short video. I just want to kind of show you where I was at. Started wiring in stuff and getting some of the components put in there. This video is more to answer a question and comments that was given to me on this, and basically about why I did what I did as far as tearing this thing completely down. The primary reason for that was the old wiring, and I only got a little bit of it left. Most of it I threw away. Is, if we can get it to focus in on it. Focus. Anyway, you can see the insulation starting to fall off of it. If you just move it around, try to even bend it, it breaks up pretty good. That's the main reason. I just completely stripped it down. Of course, I also wanted to pull the caps out since they were all original in this, and restuff them, which I have done. So there's the rest of them there, one or two in there. Plus I checked some of the resistors were out of tolerance, so I've got replacements to put in, all carbon comp. But the main reason why I tore it down was to replace the wiring in it. You don't have to do it that way, you can do one wire at a time. But I've done so many radios, plus I'm an engineer by trade, retired now, but so it's not really that difficult for me to put this thing back together as far as wire dressing goes. The other thing too, I take a lot of photos because I'm lazy. I don't want to have to work at this. It's just a hobby, so I don't have to redesign it. So the wire part is easy to do. Basically, well, I get a pointer here. For the most part, if I can get in here, a lot of wiring, the brown wires in here are for the heaters, and the black wires is negative, B minus. So I run those up tight in the corner here, and as tight as the chassis as possible. Hold on a second. Alright, I'm back. I had to go answer the phone. Anyway, as I was saying, a lot of the black wires is the B minus. This is a floating chassis, so it's not actually ground. So you have to run a B minus lead through, or ground lead all through on the unit. And I keep those wires along with the heater wires up tight in the corner or tight against the chassis, and most of the wiring will stay pretty tight. These B plus leads here, the red leads going to the IF cans, one will go up here and there'll be another wire feeding off of it. I'll keep those down tight to the chassis. The other thing too is anytime wires cross, you have this blue wire coming from the plate here and feeding down into the IF transformer. Then we have a black wire will come across here and hook down in here. You want to cross them. It's fine as long as it's at preferably 90-degree angle, but any angle, as long as they're just not running parallel to each other. If they run parallel, not only can you get capacitive coupling, but you can also get some inductive coupling too. So inevitably you got to run wires across. So you try to run them with at an angle, and again preferably 90 degrees. That reduces any coupling. These two wires here, they're feeding, they'll actually go to the volume control, and they're twisted to reduce any interference. These are actually going to be coming out of the IF, the filtering, and feeding. They'll be mostly audio, so on both leads, so we twist them together when they come down into this point. What that does is keep these from becoming an antenna, because the audio output tube is right here. Now, as far as the components go, where to feed these to and how they are routed, that's where the pictures come in handy. There's numerous places, a lot of your components sometimes in point-to-point wiring can be put in place, and some of those places may not be the best place, which would have been determined by the engineers at the time this radio was designed. The way they do a lot of that, part of it's just from experience and learning and training, but the other part of it is when they do the prototyping stage. They build the radio up in a prototype and then run it and find out if they need to do any other things to it, change component values, adjust where the components are, lead lengths, and so forth. So anyway, I take quite a few pictures of the radio, and that'll give me an idea where the components originally laid out. Now this cap here, as far as I'm concerned, should go down. I don't like it where it's at here. It would be better if it was laying down closer to the chassis, and actually in a later model they did do that. This one here for some reason seems to be awful tight right here. I don't think I moved it to take the picture to get the screw in here, so it's got enough lead length. There's a bend in it right here that should be setting more over here to get it away. Again, I know in a little bit later model of this they did that. And how do I know a later model? Well, simply from the SAM's picture. This cap is further away from the coil. This one's, the other one I said should be laying down closer, is actually laying down tighter. How I know that I'm pretty sure that this, and it's going to be hard for it to get on the video, but that it's probably a little bit later, is the way this twisted pair is done right here. This is pretty much one single twist all the way through from one end to the other end. So it would be kind of like what I showed on those other two wires, where they probably connected one end and then just twisted it up and then connect here. Whereas in this radio, the way it was done, the wires were actually physically connected, a little bit long, and then they went to the center and twisted it. This twist is going one direction, this twist is going the other direction. They twisted here. This was an early thing that was probably discovered fairly early on, that needed to be a twisted pair, and so they started doing it, and then later they started changed the way they did their manufacturing to these not having to do it after it's connected up. Now, a couple other things to note interest on this radio, and I don't know if I can get in here close enough in here, but if you can see the end of my pointer, there's a cap right here that comes down and goes to this point, and this point's got two other caps feeding off of it. Well, if I move along here, maybe I can bring another picture of that. Sorry about the shaking a little bit. I got my left hand shakes. Here's a picture of the way the radio was wired, and here's that cap connected here. This cap's connected here, and this cap's connected here. This is the plate of the detector tube, the 12SQ7, and this cap right here goes down, and you can't see where it connects, but it connects to the grid of the output tube. This is the coupling cap. No, wait a minute. No, this is the coupling cap going down there. Sorry about that. This one here's tone cap. It's tone correction cap right here. This one's the coupling cap, but both of them are coming off the plate. But this here, which actually by color is 100 picofarad cap, is connected here to the plate. On this side here, it connects here. This is ground, or B minus actually. This will be the electrical ground. So this cap is a 100 picofarad that's pulling off to ground. And that's standard normal connection. What that's for is if there's any of the IF still left after it gets through all the other filtering and gets through the detector and its filters and gets through the volume control and into this tube, it gets amplified. This will bleed off whatever's left of it. So it's completely gone. Now the interesting thing to note is if we go to the schematic, there's two actual mistakes on this cap. Number one, there's this cap that they're talking about, that same cap, but it's actually hooked into the grid, and of course then goes to ground. But they're also showing as a 330 picofarad. Now the color dots on it's 100 picofarad, so which is more standard size, 100 to 120. I have seen them as high as 250, but 330 is getting pretty darn high to bleed off that, decouple that IF. And it should be on the plate circuit, which would be right here. And the way the radio is wired, that is where it's connected. And also the picture that Sam's has got shows it connected here. So there's the .005 coupling cap going to output, and this is the tone correction cap here. So this one here will be this one here, and .005 is this one, and then here's that 100 picofarad that they're saying is a 330 and saying it's hooked into the grid and not the plate. Well, the better place is the plate. Again, if we look down here on Sam's, it gives it a number 20 on it, and we go to the picture of it and bring it up, and we go up here and we pick off 20, follow it down, it goes to that cap. And like I say, it's difficult to see, but the wire is going right here from the end of that cap to here. Besides that, the grid is, I believe, different. It's pin 2. Yeah, grid is pin 2 on that tube. If it was going to the grid, this would have to be down underneath this cap, right in here, down about there's where pin 2 is, and it's going up here. So where the others, this cap and this cap is connected. So they didn't follow their own picture they took when they drew up the schematic. So, and then they didn't read the value. It's possible it had a 330 in it, but that isn't what is in this radio, and we'll go with what's in here. But I wanted to show that. But again, I take pictures so I can get these components exactly where they are, as close as possible to where they were. As far as the wiring, I'm not as concerned about the wiring, because there's some simple rules with it that's pretty easy to do. Again, you can see that they're following the same rule, keeping everything, a lot of the wiring along this area here. That gives two planes here. Now, even though the chassis is not radio ground, it's not floating either. It is connected as far as signal goes and charge goes. We have a 220K resistor that takes care of any charge buildup, which will connect the two grounds. This is your chassis and here's your B minus. And then we've got a 0.1 cap that takes care of any potential signal that can get induced on that chassis and takes it back to B minus as well. So the chassis doesn't float. If it was floating and not connected this way, then what would happen is not only can it build up some charge on it, which can get pretty high voltage, get pretty close to the B plus voltage, but it can also act just like an antenna out there, and it can just start picking up all signals that's in the radio, the RF signals, the IF signals, and even some audio stuff, and cause all kinds of headaches throughout the entire radio with interference. That can actually literally just shut the oscillator off. It just messes with it real bad, so the local oscillator will shut down and you'll get hum and noise in the audio. So but anyway, so that's the reason why I did it was because the wiring was the old rubber coated wiring, which is the radio is actually a little bit on the new side to have it, but they were still using a lot of it. The other thing was of course I was going to stuff the caps, and I just pulled them all out to do that since I was going to have to replace all the wiring. And again, it's not that difficult to get the wire dressing. Some simple rules basically is try to keep your parallel connections to a limit. Now these two wires here running parallel here is perfectly fine because they're coming from the same point. This is just a B plus that's in here and feeding up this way. But try to keep, you know, the lowest voltage and like your ground, and as well as the filament down tight in a corner of the chassis. And that's one reason why, if you notice on a lot of radios, they do run the tubes all down one side and then maybe turn back. Now if they start getting more tubes than what's in here, then they have to start finding other places to put them. Generally what they'll do is they'll work at the front end first, and we'll just kind of place around. Here's where the tuning condenser cap is, and we'll just kind of work around it, placing tubes. But if we got a large the chassis long enough and everything that we can keep the tubes, all the tubes we've got in here along a path that's near the edge, then we can keep a lot of your filament or heater wiring and certain other wiring as B minus wiring, as well as maybe some of the cathode stuff, all down in this tight corner, and keep it from causing any problems. And then as far as the components go, you just try to map them out so that they won't give any problems. Generally, as far as components giving problems, will be up in this area with the audio. Down in this area around the front end of the radio, just basically keep the leads short. That's just the standard rule. Anytime you're dealing with RF, the shorter the leads, the better. But I hope that answered the question and everything. So, and kind of show you where I'm at. I'll keep kind of plugging away at this and do a video every now and then as I get along here and stuff. So I want to thank everybody for watching and your comments, and as well as subscribing. If you like this video, give it a big thumbs up. If you're new to my channel, I do stuff like working on radios and TVs, restoring them, as well as do a lot of theory. I'm doing right now I deal on AC circuits. It'll be a long series of videos, and stuff on TV circuits as well. So if you like what you see, and you haven't, and you're new here, just you want to see more, just subscribe, and that way you'll be updated every time I upload a video. So thanks again, guys, for watching, and everybody have a great 4th of July. Have a great weekend this weekend, and everything. So I'll see you all on the next video. Thanks again for watching.